Most likely you started out factoring trinomials that look similar to this, where the leading coefficient is 1. In this video, we will learn to factor trinomials in which the leading coefficient, or the coefficient on the x squared term, is not 1. Before factoring trinomials of this type, consider the following binomial multiplication using the FOIL method. And notice here we have coefficients on the first terms. Multiplying the first terms, we get a 6x squared. Multiplying the outer terms, we get a 8x. Inner terms, 15x. And last terms gives us 20. Simplifying, we have the following trinomial. If we look at where these numbers came from, you'll note that the product of the first terms in each binomial must equal the 6x squared. The product of the outer terms, which in this example was 2x times 4, plus the product of the inner terms, which is 5 times 3x, need to add to equal the middle term of 23x. And last, the product of the last terms in each binomial must be 20. To start factoring this trinomial, make sure to factor out the largest common factor. There is no common factor other than 1, so no action is needed. Next, we need to find two first terms whose product is 3x squared. Since 3 is a prime number, there's only one option. Checking, we see the first two terms multiply together to equal the 3x squared. Next, find two last terms whose product is equal to the constant term in this polynomial, which is negative 8. There are 4 pairs of factors of negative 8. It is important to note that since the first terms are not identical, changing the order of the factors of negative 8 in the binomial factors results in a different product and need to be considered as well. Knowing that all first and last products will check, we systematically take each set of last terms, checking by multiplying to see if the sums of the outer and the inner products is equal to bx, or the middle term of this trinomial, which is negative 10x. So we'll start with the first pair. Multiplying the outer and the inner, simplifying gives us a negative 5x. Since this is not correct, we go on to the next pair. And it should be noted that the next pair, the only difference is one is positive and one is negative, have been switched on the same two factors, and as we follow this through, you'll notice that we ended up with a positive 5x, where in the last one we had a negative 5x. We could have skipped this step knowing that we aren't getting the middle term of negative 10. Moving on to the next factor pair of negative 2 and 4, we inspect the outer and the inner products, simplify by adding. The middle term is a positive 10, and we need a negative 10. This tells us that we only need to switch the signs of these two factors to achieve the correct middle term. With using a positive 2 and a negative 4 as the last terms in each binomial, multiplying the outer and inner to check, simplifying, we have the desired middle term. It is worth noting that the remaining factor combinations will not work, so we can stop after finding the correct factorization. Those other possibilities needed to be listed since the first terms in each binomial are not identical. Changing the order of the factors of negative 8 in the binomial factors results in a different product and needed to be considered as well. Had this last factor pair not worked, we would have continued systematically inspecting each pair for the right combination. To factor this trinomial, we check to see if there is something other than 1 as our largest common factor. There isn't, so no action needed there. Next, we need to find two first terms whose product is 10x squared. Since 10 is a composite number, we have two options to consider. 10x and x will give us a 10x squared, as well as 5x and 2x. We move on to our constant term. We're looking for two numbers that multiply to give us 7. There are two pairs of factors since 7 is a prime number. Because all the coefficients in this trinomial are positive, we can eliminate the negative factors that we have here. Our mission is to pick the pair that results in a middle term of 37x. We'll start with one of the first term options of 10x and x and try the factor pair of 1 and 7, multiplying, simplifying, and looking for the desired middle term. So this pair does not work. But staying with the 10x and x, the next arrangement needs to be tried as well, because we will end up with a different middle term, as you see here, with those two factors switched. This, however, does not work. We've tried the two possibilities that we have with these first two terms being 10x and x. So striking out on finding the correct binomials for this factorization, we move on to the second first term option and start over with the last term factor pairs as options. Multiplying with placing 1 and 7 and simplifying, we have found the correct factorization for the given trinomial. To factor this trinomial, again, consider a common factor. In this case, we do have a common factor other than 1. The largest common factor is 4x, so we will factor this out of each term. Then we will begin the process of factoring the remaining trinomial that is the result after the first factorization. We're looking for the first terms whose product is 6x squared. Since 6x is a composite number, we have two possibilities for the first terms in each binomial. Our constant term is 10. Factors of 10 are the following, reversing those orders to make sure we cover all possibilities. And the fact that two negatives multiply to give us positive gives us the other list. Our middle term that we're trying to determine is a negative 19, which means we can eliminate those positive factors for the last terms of the binomials. So we begin our process by checking multiplication to see if the sum of the outer and the inner of our bx, or negative 19, is achieved. Note that both first term options need to be considered. Plugging in the values and testing them, it ends up, it is 3x and 2x as our first term, and the factor pair of negative 2 and negative 5. Multiplying here, we have a negative 4x. Our outers is a negative 15x, which does add up to be the negative 19x. To factor this trinomial, first rearrange the terms in descending order. Having done that, determine if there's a common factor. There is no common factor other than 1, but the leading coefficient is negative. To make this trinomial look like the others that we have been factoring prior to this, that follow a pattern, we will factor out a negative 1 so that the leading coefficient is positive. Now we will work with the remaining trinomial to factor this. So we're looking for factors of first terms that multiply to give us 3x squared. This is prime, so we only have one option. Here we have our constant of negative 8. Showing here are the two possibilities. doubled because of switching the sign of a positive and a negative factor. We're looking for a middle term of negative 10x. We only have the one option on our first term. We will plug in each one of the pairs looking for that desired negative 10x, and here is our factorization for this original trinomial. Testing, here on our outer is a negative 12x, inner is 2x, which do add up to be the negative 10x. It's important to note that the negative one that we originally factored out does need to be included here in our final factorization. At any time, this should multiply to equal the original polynomial that was given.